everyone, and welcome to The Cut. I'm very excited to start this episode of The Cut, as The Cut was traditionally a video call show. Now I have the great opportunity to do a cut episode here in our technical center in Kempten, Germany. I'm with my colleague, Robert Frei, product manager. Hey, Robert. Yeah, thanks for joining me today. But not only am I joined by my colleague, Robert Frei, here in person, I'm also joined by my colleague, Rob Bokram from CERATIZIT USA via video call. Hey, Rob, what's going on?
How you doing, Brian?
Fantastic, fantastic.
Good.
Yeah, thanks for taking the time to be with us today.
My pleasure. Glad to be here.
Cool. So, in this exciting episode of The Cut, one of the first ones we're doing in a live type setting, we're going to be talking about indexable milling cutters. Indexable milling cutters is obviously a very broad topic within the metal cutting world, but CERATIZIT has quite a few diverse solutions for metal cutting or indexable milling cutter systems. And we're going to take a look at a couple of those milling cutter systems today. Robert, can you show us a little bit about which systems we're going to take a look at?
Yeah, today we will look at four very famous tool systems here. Double-sided face milling system, bottom milling system for copy milling and aerospace application, as well a very high positive insert milling cutter for shoulder milling, as well for shoulder milling, a very useful tool with 8 cutting edges. This is what we will have a look on today.
So we have 4 different systems here. Why would anyone choose one particular system over another? Like, what are the key differentiating factors between one system to another system?
One is the understanding is, yeah, you have different applications, you have different work pieces, different machines, and so on, different customer needs, and this helps you to select the right tool. But first you have to know the customer needs, and if you know that, you can select. It depends on workpiece, material, clamping situation, like here on the machine, and different stuffs, you know. And
so there's really a lot of factors that play into why you would choose one system over another.
Yes, and you have a wide range of solutions with insert milling tools. You have different grades, different chip breakers, different insert sizes, one single-sided inserts, double-sided inserts. You can use one tool for different application, and that's what makes it a bit tricky to select the right tool.
So we'll go over to the other Robert. We'll call him Rob just to keep things going. I got the Roberts with me today. That's always great. Rob, tell us a little bit about indexable milling in the US marketplace. What are maybe some application fields where our systems come into heavy use?
Well, if we're going to talk about the 4 systems that we're dealing with today, the 211, the 273, 251, and 491, I can speak to applications for those 4 systems. For example, the 211, as Robert implied, it's high positive cutting action insert, 2 edges. And the nice thing about this cutter system is the ability for it to take very heavy depths of cut. We offer it in 4 insert sizes up to 20 millimeters. So that 20 millimeter insert can cut up to about 740 thousandths depth of cut. That's a pretty heavy depth of cut for any cutter system. So you're going to see this used in aerospace applications, machining aluminum aerostructures or titanium aerostructures, where you need to remove a lot of materials, whether you're shoulder milling or trochoidal milling. That system is really a system for heavy machining. Other industry segments would be oil and gas, heavy machining, for example. You know, a lot of casting manufacturers now are providing value-added services. For example, they'll do the Op 10 or Op 10 and 20, where they remove the scale or remove a lot of material from that component before they send it to their customer, so that the customer actually gets a component that's semi-finished. So cutter system like this is ideal for that. The other 90-degree cutter system is the 491. Now, this is a system that is a negative insert design, but the advantage is it's got 8 cutting edges. So instead of just 2 with the 211 system, you get 8. But it's still very soft cutting. The nice thing about this system is all the engineering is built into the cutter. Precision located pockets, precision ground inserts that index to within 8/10. So, you can get really good finishes because it's an exact 90-degree approach angle. So you're going to get very good shoulder finishes if you're shoulder milling, very flat surface finishes. And this is a system that's, of course, you're limited to depth of cut, but we do offer it in two designs, a 9mm design and a 12mm design. The 12mm design, you can get up to a 0.236-inch depth of cut, which is pretty decent. And again, very soft cutting, so it acts like a positive insert design. We even have an F10 chip breaker for machining aluminum. Even though it's a negative style insert, we can use this cutter to machine aluminum quite effectively. The 273, this is a cutter system that's very economical. 16 cutting edges. Now, of course, with 16 cutting edges, you're going to be limited to your depth of cut. In this case, 0.128 inches if you use all 16 edges. So
we can certainly see here, Rob, the one that we got here today is definitely been making quite a few cuts. So this is a real world example of a 16-edge cutter here. It's done a lot of cutting over the years.
Yeah, it's a great cutter system, and it's really a great system for cast iron machining, and I think a lot of the applications are automotive applications for this cutter system because the depth of cut's limited, but it's a high-density cutter system, and it's got what we call them, used to call master finish cutting edge, which is really a wiper on each insert corner that can get you some very good finishes down to, depending on machine, conditions and parameters and material type, down to, say, down to a 2RA, which is, like 80 micro. And we also offer a wiper. So you put that wiper in there and you get down to 1.2 RA. That's, a little over 40 RMS. So it's a really phenomenal cutter. It's really maximum economy cutter because of its 16 cutting edges and its ability to produce very fine finishes.
So that wiper, that's an insert with like a special geometry that kind of helps to give a finished surface, a nice finished surface.
It's set slightly below the rest of the inserts, so it acts as a cleanup wiper, right?
Cool.
So it provides the final finish on that surface.
Yeah, it's a really diverse system.
One or two in a cutter body, depends on the diameter of the cutter body. Typically one is sufficient for the size cutters that we sell.
Cool.
And
we
then
had
the
one more
251
system.
is the last cutter on the list. And this is what we call a button cutter or copy mill. It's designed with a round insert. We offer the 5 different sizes of the round insert, so up to size 20mm. So you can actually get fairly decent depth of cut with that cutter body. The nice thing about the button cutter one is it can do everything, right? It can do any milling strategy that you can think of. It can plunge, it can ramp, it can circle interpolate. It's actually a very good circle interpolation tool because of the way cutting forces act when it interpolates. And you also get better ramp angles than a 90-degree cutter would. So you can actually interpolate more quickly and remove more metal more quickly with that design cutter. The other thing is because it's a round insert, it's very good for machining tough materials that generate a lot of heat because you distribute the heat and cutting action across a larger radius of that insert. It's very stable. It's a good tool to machine rough surfaces, machine scale, or machine across welds because that insert's a very stable design. It's not like a small corner radius on a square shoulder. A 90-degree style tool, you can distribute the cutting forces across a larger edge.
So it's a powerhouse. Yeah, it's a powerful.
And it actually, at lighter depths of cut, it's 25 thousandths to 50 thousandths, it acts like a high feed cutter. So you do get the ability to do fairly high metal removal rates on lighter duty machines. So it's good. It's a good cutter for machine shops with light duty machines that want to generate fairly good metal removal rates, but don't have the power to do so. And that cutter can actually give you pretty good metal removal rates without really stressing the spindle or stressing the torque and power curves.
Yeah, that's really awesome. Yeah, thanks for that breakdown of the systems, Rob. I find it so fascinating with these milling systems. I mean, obviously with all types of machining, it's always a wide variety of factors that play into what the right solution is at any given time. You have the material that you're working with, you have the system geometry, the holder geometry, you have the insert geometry plus the insert substrate, the carbide grades that you're working with, the coatings, the chip breakers. I mean, there's such a complex interaction of attributes that lead to choosing the right solution. Tell me, Robert, I mean, what do you think about this kind of stuff?
Yeah, I think if you have a full understanding of the interaction between workpiece material, tool geometry, tool material, and cutting parameters, this is essential if it comes to producing with maximum power in demanding applications. If you have this understanding, it's very simple to select the right tool, because you have each time a wide range of solutions. Yeah. For me, it's brilliant.
Yeah, I mean, it's great that we have quite a few solutions. What are some of the challenges, Rob, to implementing our systems in the U.S. market? Like, what are some of the hurdles that people may find or may have?
Well, we actually have solutions for a lot of the challenges that manufacturers have. There are a lot of challenging applications in the industry. Machining, new duplex materials, or high nickel, high chrome alloy steels, or bimetal machining in automotive applications. I mean, but we have solutions for all these challenges. I mean, we have grades for machining hardened tool steels. We have probably the best grade in the world for machining titanium in the CTC 5240. I think that the challenges we have as a company is really trying to train and educate our distributors and our end users how to use our tooling correctly, because in many cases, I think companies don't optimize the use of the tooling they have. They haven't gone through the process of looking at every aspect of the process they're using to get the maximum number, maximum amount of metal removal, or the maximum economy when machining any given part. So I think part of the challenge is education and training, and having good people in the field. And we have very good people in the field, highly technical people in the field that are capable of doing these things. And product management also is obligated to help as well, and we do. But I think that it's a constant battle to get the customer to understand what's in the marketplace, what tooling is out there to solve this problem. And the other thing is understanding the customer's problem. I mean, I think as a product manager, job one is understanding the market well enough to understand what the problems are that the customers are having, and then design solutions around those problems. And I think CERATIZIT's done a good job with that. And we continue to innovate. We are innovators. We are, I think, the most innovative company. And our solutions, I think, are optimized quite well to solve a lot of these challenges.
Yeah, that's awesome, Rob. Yeah, we have, some really nice solutions here. But one of the big factors often is, besides the substrate, is also the coating of the insert. Maybe, Robert, you could tell us a little bit about the coating that you find on these particular inserts.
Yeah, here on these inserts, you can see our dragon skin coatings. These are coatings. The main rule of the coating is to protect the carbide of the heat. And if this is given, you can have a good working application. That's really great. It doesn't matter if it is a PVD coating, you use it mainly for wet machining with emulsion, or it is a CVD coating using by dry machining in high cutting conditions. This is the challenge of the coating.
Yeah. Cool. Well, it's great that CERATIZIT has solutions for those. So we have these 4 systems here, obviously, and we're featuring them in particular because CERATIZIT USA is doing a special offer on these particular systems in the marketplace. Do we have other systems, that we haven't looked at today in the indexable milling range? Rob, do you have any insights there?
Well, of course, we do have other systems, some more conventional, for example, some regular positive insert design systems that are legacy systems that have now been replaced with negative style inserts with twice the number of cutting edges. So those systems are still there. We still sell them, but there are also some interesting systems that the marketplace has embraced. For example, high feed milling. We offer a high feed milling system with 4 different insert sizes, with the ability to go up to 130 thousandths depth of cut. Compare that to, say, a button cutter that may only run at 50 thousandths depth of cut. So you've got an advance in metal removal rates by the high feed system that in many cases beats any other conventional system. But of course, when you accelerate your feed rates, which you have to do with these high feed systems, you have to have horsepower because it's a linear relationship between
so the
feed
machine
rate
plays a factor there as well, huh?
Yeah, and also we have an interesting new system out that's called the SEC system, right? It's a suction effects cutter. Yeah. And this is a really cool cutter. It's basically what we do is we've put a cap on the end of it and optimize the angle and location of the coolant holes to actually create a suction effect in the pocket itself to pull chips away from the surface and back towards the back end of the spindle, right? So you're actually in certain applications, especially automotive applications, combustion side of crank and or cylinder case applications, or exhaust manifold, or components like that, where you've got all these cavities as part of the part, and you're machining to cross all these cavities. You don't want to contaminate them because it's at least one more step to clean that part out and get rid of all those chips, which is expensive, time consuming, laborious. So if you can actually keep the chips out of the part, it's a huge advantage for in this case automotive component manufacturers to save at least one step and reduce costs. Cool. So it's a very novel system, and we've applied this concept to counterboring as well, where you're pulling, if you're counterboring a hole and finishing up, you can pull those chips out and keep them out of the part, out of the inside of the part. So we've extended this concept to making specials that utilize this concept. Our ability to 3D print tool steel bodies allows us to create special configurations with whole coolant configurations that are optimized to do just this. So we have that capability as well, which I think sort of puts us into the realm of innovation that puts us at the head of the class in terms of these kind of designs.
Yeah, that's awesome, Rob. Yeah, really innovative stuff, especially in the indexable milling insert range. So again, I mean, a major factor besides the performance of the tool is also the economics of any given system. How does economics come into play when choosing a system?
Yes, economic is also a very big solution today. Here in economic, often pricing is one of the most topics, because here you have a face milling system with 16 usable cutting edges. It means this system divided the price of the insert by 16. And if you have just a tool system with 2 cutting edges, the price is just divided by 2. It means often a double-sided tool solution is more economical for price-sensitive customers, useful, and so on. Yeah, economical also is the tool life. If you have a negative tool system but it doesn't work in your application, maybe it's better to use a high positive system like this one here, and you solve these problems and you get a higher tool life, a better process, better reliability, and so on. Yeah, that's very important to know. You always have to find the right solution for the customers, and this job is done by our great sales guys in your country, all over the world. We have a great staff of CERATIZIT sales guys, application managers, and so on. Yeah, and they will select the best economical and pricing situation for the customers too. Yeah.
Yeah, so it's not always about price per cutting edge or something like that. It's about choosing the right system to get the most out of it.
Yeah,
well, that was
I think there's price and there's cost, right? So
yes.
Price is price, right? It's what it is. But cost is a different thing. Yeah, I think you're looking for productivity, and anywhere where you can increase your productivity by choosing a better milling system, it doesn't matter what the price of the insert or the cutter body is. If you can get more parts out the door, you're going to make a lot more money, a lot more margin, and the cost of the tooling is basically free. I mean, if you improve your productivity by 15 or 20%, the cost of the tooling is only 4% of the total cost of manufacturing something. So, if you improve your productivity, you're way ahead of the game, and you paid for that tooling multiple times over. So it's really about choosing the right system to maximize your productivity, whether it's metal removal rate, whatever it is, cycle time, whatever. So I think it's more about cost than price.
You got to keep those chips flying, right? That's the name of the game.
Keep flying.
All right, well, thank you guys so much for joining me today. That was a really informative conversation about our milling systems. Like I said, go ahead and like and subscribe to our YouTube channel if you want to keep hearing interesting conversations like this about stuff from inside the world of CERATIZIT. Also, please take care to check out on our US website from cuttingtools.ceratizit.com. You'll find a landing page which features all of these systems, as well as a link to this video. So thank you, Rob, for joining me today on The Cut, and look forward to talking to you guys next time.
My pleasure.
Thanks, guys.
Cheers.